Hello and good morning to everybody, or good day to everybody. Um, what we're going to do is we're going to continue on with the lesson 8 that we started yesterday. Um, but before we get into the last two examples, I was actually um, just going to talk about example number 5. I did a very fast approach on this one, and then I looked at my answer, and I actually did the shortcut for this. So what I'm going to do is I'm going to go back to example number 5, and in that case also use the formula um, for the pH. We will get the same answer, but this is just one of the shortcuts that I found. So I will show you every step for example 5. Okay, so let's do that first. I just have to do, I think I could do that on this page here. So I'm going to redo this one here. And like I said, it's going to be very the same answer as what we're going to get in here. So let's take a look at that one. Put that there. Okay, so it says here the pH is equals to the negative logarithm of H plus. And then we are probably thinking, what is an H plus? H plus is the hydrogen ion concentration. And so it says here, a lake affected by acid rain has a pH of 4.4. A person suffering from a heartburn has a stomach acid of pH of 12. How many times greater is the hydrogen ion concentration to the hydrogen concentration of the stomach than that of a lake, expressed as a whole number? So this is the, like I said, I did that a shortcut yesterday, but this is like actually the way of using the formula. So let's start off with the lake, acid rain. Lake, a lake affected Okay, so we know the pH for that. pH is equals to 4.4. So what we're going to do is first, we're going to use a formula. pH is equals to the negative log of the hydrogen ion. Okay, so I'm going to put in 4.4 here. So 4.4 is equals to the negative log of the hydrogen ion, like that. So when you come across something like this, you can think of this H plus as the x variable. So you can think of that as the x variable. Now, how do we figure this out? Okay, so we can replace H plus with x if you want. We're going to now change the logarithm into exponential form. Let's write it like this. So 4.4 equals the negative log of x. So we're just going to assign h plus, okay, a variable x, okay, because we don't usually see h plus in our equation. So how do we figure this out? So in the logarithm, we can change that into an exponential function. So if we change that into exponential function, it will become, remember this is a log, common log, so this is a base 10. So 10 to the exponent 4.4 is equals to the let's divide that first. I forgot the negative. Let's divide it by negative 1 first. I'm going to go here, divide by negative. So it's going to be negative 4.4 equals to log of base 10 of x. And then we can change that into exponential form. So 10 to the negative 4.4 equals to logarithm equals to x. Equals to x. Okay. So what have we done here? We've changed the h plus to x so that we can just have the x variable to solve because that's what we're going to be solving for. And then we divided it by negative 1 on both sides of the equation. So this is going to be negative 4.4 equals to the logarithm of x. And then we've changed the logarithm into exponential form. So it's 10 to the exponent negative 4.4 is equals to x. Now, when we get to that part, we can just grab our calculator and calculate what's 10 to the negative 4.4. So, and that's going to be a really, really small number. So let's just take a look. So 10 to the exponent. Okay. So some of you have a y to the x or x to the y button, or sometimes your calculator has the looks like an upside down v. That's for your exponent. So 10 to the negative 4.4. And like I said, this is going to be a really, really small number. You get 0 decimal 3981. Now, this is going to be used in chemistry. Like I mentioned yesterday, that this is a type of chemistry question. With your chemistry question, you're probably, because it's such a small number, you would have to change that into a scientific notation form. And yeah, but this is not science. Okay, so now what we're gonna do is, this is the number that we get. So this is the hydrogen ion concentration, okay, for the lake that's being affected by an acid rain. So that's how much the hydrogen concentration is. Now, what about the hydrogen concentration of the heartburn in the stomach? Like when somebody has a heartburn in their stomach. So stomach, what we're gonna do again is for the H plus, the hydrogen ion, we're gonna just assign that as a X, so that's something that we are familiar with, a variable. They said the pH for the heartburn is 1.2. So pH for the stomach acid is 1.2. So we're going to use, again, the formula. pH is equals to negative log of hydrogen concentration, ion concentration. And then, like I said, we are going to change that H plus with the variable X. And then pH, we're going to substitute that with 1.2. So 1.2, that's this one here. And it's negative log of X. Okay. So the next thing that we're going to do is we're going to divide both sides by negative to get rid of this negative here in front of the log. So that becomes negative 1.2 is equals to the log of X. And how do we deal with this one in here? From the logarithm, we're going to solve for X, we're going to change that into exponential form. And again, this is a common log. That means the base is base 10. We can write that as 10 to the exponent negative 1.2 equals X. Okay. And then this is just a matter of typing into our calculator. I'll just go like this. So x is equals to, and then we're going to get a decimal there. So let's go ahead and calculate that. So 10 to the exponent, 10 to the exponent of negative 1.2. And again, we're going to get a decimal there. So I'm going to try to write as many decimals as possible. And if you are in chemistry class, I guess in either chemistry in our class or chemistry in university, maybe you're going to do this one. You're going to write it in a scientific notation, but we're not going to do that. 0.063095. And there's quite a bit more. Okay, and then that one is the concentration of the hydrogen ion in the stomach when somebody has a heartburn. So now you're probably thinking, well, what do we do with these numbers? Okay, what are we going to do with these numbers? So what we're going to do, erase this part here, is that you got these two numbers, concentration of the lake, of hydrogen ion in the lake, and then this is a concentration of hydrogen ion in the stomach. But the question is, how many times greater is hydrogen concentration in the stomach? So they're asking, how many times bigger is this compared to that one? So how can we figure that out? How many times bigger is this compared to that one? The way to do that is, I'm going to go back up here. Up here. Now that we have concentration of H plus hydrogen ion for lake and stomach, we can compare it. Okay, so we can just take, this one is so much bigger compared to the other one. It's going to be 0.063095. And then, of course, if we count all the decimals, 734 divided by 0.0000391. If we take that divided by that, we're going to get, okay, so I'm keeping all the decimals there. 0.0000391. And then we get the same thing, 1,584. And we got a 0.9 in here because 1,584, because we didn't write down all of the decimals there. Now, you're probably thinking, well, how is that thing over there? Like, how did I get this part to this part? Okay, let's see. So we know that the concentration of hydrogen ion for stomach is this, right? 10 to the negative 1.2, right there. And then the concentration of hydrogen ion for the lake is 10 to the negative 4.4. Okay, well, this is going to be more compared to this one. So how do we do that? When we compare, we said how much is the concentration of the stomach to the concentration in the lake. Stomach would be 10 to the negative 1.2 divided by 10 to the negative 4.4. Okay, now let's see. This is a negative exponent. So that means if it's a negative exponent, we have to take the reciprocal of that. So this is the same thing as 10 to the negative 1.2 is if we take the reciprocate of that. This one will be in the denominator to make it a positive exponent. And then this one, 10 to the negative 4.4, and because it's a negative exponent, we have to take reciprocal of that. So this one goes to the numerator to make it a positive exponent. And this is actually what we were doing yesterday. Okay, so I did a shortcut yesterday, not using the pH calculation, but we will come to the same answer of 10 to the exponent 4.4 divided by 10 to the exponent 1.2. And we get 1580. Yeah, should have been 1585. Okay, so it's 1585 times more H plus. Okay, so that's the explanation for that piece. Okay, I'll just put this. I will attach that also on our notes. Okay, so there we have it. Now we could get to the actual example 6. So example number 6 looks like this. A certain culture of bacteria triples every 25 hours and grows according to the formula. So, okay, they're giving us a formula, and let's see, what does the formula look like? A equals to P times 3 to the exponent R times T. It says here, the initial count of the sample shows 1,000 bacteria. So they're telling us there's an initial, at the beginning, 1,000 bacteria. And it says here, determine the rate of growth in this culture. So the rate is the R. The R in here. So let's take a look. Letter A. A is equals to P times 3 to the exponent R times T. So the rate of growth. And it says here, it triples every 25 hours. So that means if I put in 25 hours for T, if T is equals to 25 hours, the amount triples. Okay, so what does that mean? The amount triples. So this becomes 3,000. And then P, when we talked about this yesterday, P is the initial amount. So initially it shows 1,000 times 3 to the exponent R. Well, we don't know what the R is, the rate growth, times T, which is 25 hours. Okay, so this is what we have. And what we're trying to figure out is this variable R. What is this R value? Okay, let's solve this. First, because 1,000 is multiplied by all of these the exponent r times 25 only applies to the base 3, not to the 1000. So what we could do is to kind of simplify this equation is to divide both sides by 1000. So divide both sides by 1000. Okay, and then of course that's going to cancel, that's going to cancel. So 3000 divided by 1000, that's going to be 3. And then this is going to be 3 to the exponent r plus r times 25. There's probably different ways that we can solve this. We can solve this using the logarithm. We can solve this by just comparing exponents. So here we can see that we have the same base. We have same base. Okay, this is actually probably going to make our life a little bit easier in terms of solving this equation. Because we have the same base, that means the exponents have to be the same as well. So I can say that this is 3 to the exponent 1, right? 3 to the 1. Therefore, 1 is equals to r times 25. So if we just focus on the exponent, okay, so we can just equate the exponent. 1 is equals to r times 25. Solving for r, so divide by 25. Divide by 25. The 25 cancels. So r is equals to 1 divided by 25. So let's do that one. 1 divided by 25. And then we're going to get a 0.04. Okay. Now, if you want, you can write that as a percent, or you can write down r is equals to 4%. Okay, so that one's not bad at all. Let's take a look at letter B. How many bacteria were there 18 hours after the initial count? So 18 hours after initial count. So let's see here. Squeeze it in this part here. So this is letter B. Now we know that the rate is 4%. We can figure out that in 18 hours. Okay, now let's take a look at this one here. Everything is in hours. This is hours, so A is equals to P times 3 R times T. So A, how many bacteria? So they're asking us, well, what is the A after 18 hours? How many are there? So we started off with 1,000 bacteria. Following the formula, base is 3. R, the rate we just found out is 4% or 0.04. And then the time is 18 hours. Okay, so let's go ahead and calculate that one. Remember that the exponent is 0.04 times 18. So on your calculator, you might have to put a brackets around there, okay, to show the calculator that the 18 is also part of the exponent. So I'm going to do that right now. Do that with you. So 1,000 times 3 to the exponent of 0.04 times 18. Okay, so give it a try. Okay, so I got 2,206 bacteria. Okay. So I'll give you a moment to try that. If you are having questions about how to use your calculator, you can either email me or you can, if you're watching right now, you didn't get the same answer as me, say, we'll try to help you out. Okay, so now let's go ahead and do letter C. So approximately how many bacteria will there be in 2 days? Now, when we take a look at these formula in here, everything is expressed. Okay, bacteria triples in every 25 hours. So the information in here in terms of the time are expressed in hours. So when we come across 2 days, we have to change that into hours. So we're going to change 2 days. Okay, so how many hours in 2 days? It's going to be 48 hours. Okay, so 48 hours. And then from there, it's pretty much the same thing as what we did in letter B. What is the amount after 48 hours? So A is equals to 1,000 times 3 to the exponent of 0.04 times 48. Again, I'm going to put that, bracket that. Okay, so let's go ahead and type it in. Okay, so I got 8,243. 8,243 bacteria. Okay, so I'll give you a moment to write that down and to just double check to see if you got it. Okay, now let's go to example number 7. So example 7 says the decibel scale measures the intensity of a sound. The loudness of a sound, L, in decibels, can be determined using the function L is equal to 10 times log of I divided by, okay, now I'm gonna do here, let's fix this one in here because it says here I divided by I naught. There should be the circle there. I naught. Okay, where I is the intensity of the sound and I naught is the intensity of the quietest sound that can be detected. So when everything is quiet, you can kind of still hear the sound of quiet. I don't know if that makes sense to you, but if everything is quiet, you hear quiet, and that's the I naught. Intensity of a sound when the quietest sound can be detected. So the loudness, let's take a look. The loudness of a rock concert is 120 decibels. Okay, so that's fairly loud. So calculate the intensity of this sound in terms of I naught. Let's take a look. Calculate the intensity of this in terms of I naught. So intensity. L is equals to 10 times the logarithm of I divided by I naught. Okay, so using this formula, I'm going to substitute 120 decibels for the L because that's the loudness. It's 120 decibels. So that's going to be over here. 10 log of I divided by I naught. When you look at this one in here, they said calculate the intensity of this sound. Okay, but in terms of I naught, you're probably thinking, well, how can we solve this equation when there are two unknowns? Well, we're going to solve the I in terms of I naught. We'll see how that looks like. So the very first thing we're going to do is we're going to divide by 10, right? 10 divide by 10 on each side of the equation. So we're going to get 12 is equals to log of I divided by I naught. And then from here, from the logarithm form, we're going to change it into exponential form. And because there's no base stated here, then this is going to be a common log base 10. So we can write that as 10, the base, 10 to the exponent 12 is equals to I divided by I naught. Okay. So we're going to solve for I. How do we solve for I? We're going to cross multiply that. So I is equals to 10 to the 12 times I naught. So the intensity of a rock concert is 10 to the 12 times the intensity of the quiet sound, the quietest sound. That's what that means. It means that the intensity of the rock concert is equal to 10 to the 12. Well, that's a lot of times more compared to the quiet sound. Now let's take a look at letter B. Letter B. What does it be? If the intensity of a normal conversation, okay, now they're telling us the intensity of a normal conversation is 10 to the 6 times I naught. It means whatever the intensity of the quietest sound, and if you multiply that by 10 to the 6, what's 10 to the 6? Like a million. 10 to the 6. That's a million times louder, more intense, rather. Yeah, more intense than the normal quiet sound. How many times is as intense as the sound of normal conversation is the sound of the concert? So there again, this one is going to be comparing how many times intense as the normal conversation is to the sound of the rock concert. So we know rock concert we're going to get 10 to the 12 times the intensity of the quietest sound. A normal conversation, we know it's 10 to the 6th times the normal quiet sound. So how much more intense is this compared to that one? So what we can do is how many times greater? More intense. So more intense, so that's going to be 10 to the 12 times I naught, the quietest sound, divided by 10 to the 6 times I naught. Then you'll see I naught and I naught cancels each other out. So we're left with 10 to the 12 divide by 10 to the 6. And then if we remember, they have the same base, so we can use our exponent laws here. Becomes 10 to the 12 minus 6. So that's 10 to the 6th. Okay, so there's a million times more intense. So a million times more intense is the rock concert compared to the normal conversation. So this means it's 1 million, 10 to the 6, which is 1 million, more intense is rock concert compared to normal conversation. Okay, so there you have it. We finally finished this whole chapter on exponential function and logarithm function and equation. So we learned so much in this unit, and it's one of the important stuff that you're going to see when you move on to university, for sure, whether it's in sciences or in finance or wherever that gonna post-secondary is gonna lead you. Anyways, so that concludes that. So I did mention that your test is on for next week on Wednesday. I would suggest that you check the blog to see what other practice questions that you can do to prepare for the test. So again, next week on Wednesday, you have a test coming up on exponential and logarithm. So for now, you can finish off whatever questions that you have. You can practice, and I encourage you to reach out if there's anything that you're stuck with in terms of a question. Just send me an email. Let me know, which question you want me to go over with you, or maybe go over with the whole class. So please let me know about those things. Okay, so I'll leave that with you. I wish you have a great day, and thank you so much for watching and fully participating in our class. And we're almost done. It's only maybe about less than 2 months away from getting this finished for sure. Okay, so thank you for your hard work and thank you for your attention. I'll keep in touch with you. Okay, have a great day, everybody. Bye bye.